Hello, I just thought today I'd look at this higher tier paper. It's the calculator paper from November 2015, and I'm only going to do questions 1 to 5, break this one up into a few stages. Okay, let's get started. Okay, before we start I thought I'd have a look at this formula sheet for the higher tier. And the difference between the formula sheet for the higher tier, which is where we get all of this, and the foundation tier is just these two here, volume of a prism and the area of a trapezium. Let's just have a look at each of these briefly. We've got a volume of a prism. It's just the area of this cross section at the end times its length. And that can be used for all sorts of things, even for something as simple as, say, the volume of a cuboid. If that formula has been forgotten, which is just width times length times height, then just come to this, work out the cross section, and then times it by its length. We've got the area of a trapezium. Nice formula here. I also say to people, if A becomes 0, then we have a point at the top here, and you've got the area of a triangle. So you can use this formula for the area of a triangle. And then we've got these ones, volume of a sphere, well, there's your volume, and the surface area is all around the outside, of course. And we've got volume of a cone, and this one's important, the curved surface area of a cone. That's just this area around the outside here, not the base. In any triangle, so this is our typical triangle, capital letters for the corners and small letters, lowercase for the sides. And we've got this relationship, the sine of an angle divided into the opposite side is always the same. So that sine of that angle to that one and the sine of that angle to that one, they're all the same. The cosine rule is very useful if we know this side, and we know that angle, so we can work out the cosine of that angle, we can work out the opposite side length there. And area of a triangle, another method than half the base times the height, is if we know an angle and two of its corresponding sides, here and here, then we can work out the area of this triangle. We don't need this other side here. And a quick look at the quadratic formula. For this equation, ax squared plus bx plus c equals 0. A must not be 0, because otherwise we'd be divided by 2a or 2, 0, and you must not divide by 0. Okay, and all we have to do, if we've got these numbers here, these coefficients corresponding to this equation there, just put them in, and we will get a solution for x when all this equals 0. Okay, let's get on to the paper. Okay, we start this first question. Here are the lengths in centimetres of 15 tables. There's all our data. Draw an ordered stem and leaf diagram for these lengths. Okay, stem and leaf. Okay, I've labelled these. You don't have to label these. The decades go down here, the 20s, 30s, 40s, that sort of thing. There's nothing in 10 that I can see, so I'm going to start off with 2, 3, 4, 5, and I think the last one's in the 60s. Yes. Okay, then we look along here and we're trying to find the smallest one, which I think is 23. I'm going to leave a little bit of a gap here in case I miss any out and I've got to fill them back in. And then we start on the 30s. There we are, we've done it. Stem and leaf diagram, and it's ordered in the sense that they're in the right size level, 23, 25, 28, 29. And we must of course put a key in. And that's all we have to do, and it's worth how many marks? 3. So I guess there's 1 mark for the key, 1 mark for putting the stem in, the leaf in, and probably getting it in the correct order. Okay, done. Delivery driver records for each delivery the distance he drives and the time taken. The scatter graph shows this information. There we are. And what's the times up there? That's his delivery times, and the distance he travels is along here. For another delivery, he drives 22 kilometers and takes 50 minutes. So this is typical of these things. So we go 22 kilometers. Show this information on the scatter graph. Okay. "50 minutes is here." So they're going to line up just there. Okay, that's that one. What type of correlation does the scatter graph show? Well, as we go along to the right, it's rising. So that's known as a positive correlation. It's linear as well, but I think all they need is positive. And we have part C. The driver has to drive a distance of 10 kilometers for his next delivery. Estimate the time taken for this delivery. Okay, 10 kilometers. Before we try and put this in, I think we need a line of best fit. So let's do that. Okay, so there's our line, and now we just read it off. 10 kilometers, let me see, I think that's 19.5 minutes. Okay, and now this one, during one of the deliveries the driver was delayed by roadworks. Using the graph, write down the time taken for this delivery. Well, that must be this anomaly, this outlier here. So he's going along, he's trying to do a distance, and suddenly he's slowed up by roadworks by about, according to this, a distance of 7 kilometers. He's been held up for quite some time. 45 minutes. Okay, done. Now this one, question 3. Ali is Y years old, Bavara is twice as old as Ali, Ceres is 3 years younger than Ali, the total of their ages is 125 years. Work out the age of each person. Okay, it's going to be algebra, isn't it? So here we go, Ali is Y years old. So Bavara is twice as old as Ali, so it's 2y. Ceres is 3 years younger than Ali, so Ceres equals y minus 3. And they all add up to make 125. So 125 equals y plus b plus c, which equals y plus 2y plus y minus 3. Collecting the y's, 4y minus 3, that's 125, isn't it? So bring the 3 over, 128 equals 4y. Divide by 4 equals y. We could use a calculator here, but it's quite straightforward. Have each of them to start with, 64. Have them again, 32. So y equals 32. This is 2 times 32. and this one here will be 32 minus 3, 29. Okay, done. Question 4. There are 18,500 gallons of fuel in a fuel tank. Fuel is pumped from the fuel tank into a plane at the rate of 1,700 litres per minute. They tell us that 1 gallon is 4.5 litres. And then the question is, how many minutes will it take to empty the fuel tank completely? So empty the fuel tank into the plane. And the final thing is, give your answer to the nearest minute. Okay, the first thing is, we've got this in gallons, and the rate is in litres. So we have to change it from gallons to litres. So let's do that first. $83250. And the next bit is, how many minutes will it take to empty the fuel tank? That's our total, 83,250, and every minute we're going to use up 1,700, so it's a division problem. So back to our calculator. $48.97 minutes. And they said to the nearest minute, so it's going to be 49. Okay. Question 5. Selena and Zoe both sing in a band. One evening the band plays for 80 minutes. Selena sings for 65% of the 80 minutes. Zoe sings for 5/8 of the 80 minutes. Selena sings for more minutes than Zoe sings. Work out for how many more minutes you must show while you're working. So basically you've got to find out how many minutes 65% is and how many minutes 5/8 is. Multiplication problems, we can use the calculator for that. %, we show that as 100 like this, times 80. We do this on the calculator. $52 minutes. And then we've got Zoe. She's 5/8. Two minutes, done. Well, that's it for today. I'll do more questions in the next video. Thank you for watching.